Alright, so let's take a look at a couple more examples for the definition of the derivative. First of all, let's define what a derivative is. A derivative is a derivative of a function is called a slope finder. All it does is it finds slope, and that's the only thing it will do for us. Okay, it doesn't do anything else, but it has a lot of applications for us. And like I said, we've spent a whole semester talking about it. In other words, it's going to generate a function in terms of that will solve for the slope of a tangent line at any given x. Be careful. The derivative is not the slope itself. We're going to talk about that later on when we get to tangent lines more. So we want to find the derivatives for the following equations. Use the derivatives to find the slope of a tangent line at the given point. So let's take a look at this first example. Now for number 1 here, we're not going to do any work for this one. This is a line. Lines have constant slope. The slope does not change for a line. So because a line has constant slope, you're not going to do any work. What this is saying is that the derivative is the slope. So if I were to write the derivative here in terms of f of x, it would be f prime of x. It's just going to be the slope of my line, which is just 2. Now this is my derivative. Now, what we want to do now is we want to find the slope at x equals 2. Well, to do that, I'm just going to plug my 2 into this equation right there, just like we did up here. If I want to find the slope at 3, I just plug my 3 into my derivative equation. So if I do that, my slope at 2 would just be 2. The derivative is the slope for a line. There's no work for that. Don't show any work for lines. Okay? I ain't lying to you. Alright. The next one now, here's where it gets changed. Here's where it gets a little testy for us. These change over time. This is a parabola. Looks kind of like this. The slope is changing over time. So to get the slope here, now we're going to use our definition. So I want to find the derivative. So to get f prime of x, we're going to take the limit as x, not x, make sure you use the right letter there, as h goes to 0. Remember our rule. It's going to be the limit as h goes to 0, f of x plus h minus f of x all over h. So everywhere there's an x, I'm going to plug in this x plus h. So we would have this, in this case, x plus h squared plus 1 minus the OG, the original function, x squared plus 1. Now I told you earlier we're going to see this a lot, x plus h squared, so we're just going to memorize that, okay? This just becomes x squared plus 2xh plus h squared plus 1. So I'd simplify the top here, minus x squared, be careful, we're distributing a negative, minus 1 over h. And again, like we said up here in the first example, anything that does not have an h should just go away. X squareds will cancel and the 1's cancel. And everything left has an h in it. So I'm just going to rewrite that down. The limit as h goes to 0, 2xh plus h squared over h. And from here, you probably realize you can factor out an h. And if you can't, you messed up. Go fix it. As h goes to 0, I get h, 2x plus h. Those h's are going to cancel, and if we let h go to 0, we get 2x. Dos Equis. Stay nerdy, my friends. So therefore, we can say our derivative is 2x. There's my derivative. Now, we're not done here because they say find the slope at the following points. So we want to find the slope at the point 0, 1. Well, in this case, x is 1, so therefore the slope, which is the derivative, that's embarrassing. The x value is 0, so the slope at 0 is 2 times 0, which is 0. If I want to find the slope at the point, what's the next point? Negative 1, 2. In this case, x is negative 1. Therefore, the slope, or the derivative at negative 1, is 2 times negative 1, which is negative 2. And if we look at the graph, we kind of see that at 0, it is horizontal, a slope of 0, and at negative 1, the slope does look like it's negative 2 down there, up there. So let's take a look at number 3. Let's get rational. Let everybody be rational here, or radical here. Doggone, mess up that joke. So, doing the same thing. I want to find the derivative of a radical function. So I'm going to do the same thing. F prime of x is the limit as h goes to 0. Now our rule here, everywhere there's an x, I plug in an x plus h. We get the square root of x plus h minus 3 minus, remember, the original function, which is the square root of x minus 3 over h. And hopefully we remember how to solve this one. We are going to use that conjugate, the square root of x plus h minus 3 plus the square root of x minus 3 there. Same thing on the bottom. The square root of x plus h minus 3 plus the square root of x minus 3. Make sure you know this one. When we simplify this, the whole purpose of multiplying by the conjugate is to get rid of the square roots. So this becomes x plus h minus 3 minus the second term squared, so I would put that in parentheses, x minus 3, over h times the square root of x plus h minus 3 plus the square root of x minus 3. Cleaning up the top a lot, notice the x's are going to cancel and the 3's will cancel. And what I'm left with is an h. So I'm going to write out what this is, okay? If you're good at the algebra, you already know that they cancel. H over all of this, the square root of x plus h minus 3 plus the square root of x minus 3. Those h's cancel, and what we're left with is 1 over, now take a look here, h goes to 0, and I'm left with 2 x minus 3's, or 2 the square root of x minus 3. And there's our derivative. F prime of x would equal 1 over 2 times the square root of x minus 3. Now again, we're not done because they do ask us to find the slope at 4. So I can find the slope at x equals 4 by just plugging it in. F prime of 4 becomes 1 over, plug in the 2, this becomes 4 minus 3 is 1, so I just get 1/2 right there. Easy peasy, pumpkin squeezy, right? All right, number 4. Same exact type of question. Let's take a look at number 4 here. Ready? Let's see here. There's all of that. For number 4, when we take that limit, we want to find the derivative first. F prime of x. We're going to get the limit as h goes to 0 of the following. 2 times, remember, everywhere there's an x, I'm going to plug in that x plus h squared plus 1 minus the original function, 2x squared plus 1. All over, oh yeah, all over h. Okay. Simplifying, mathematical marine motto. Again, this top here, x plus h squared, I mean, we've seen it here. We know that this is going to become x squared. So if I want to write it up here, I can. This is just going to become x squared plus 2xh plus h squared. And I'm going to multiply that by 2, and that's going to be giving me my new fraction here. 2x squared plus 4xh plus 2h squared minus, distribute that negative, 2x squared minus 1. Oops, I forgot my plus 1 there. So let me go ahead and erase this real quick. When I did the first part, there we go. That was odd. Okay, there we go. There was that plus 1 there. I forgot about that. minus 2x squared minus 1. Now, I knew I made a mistake. Because remember what I told you earlier, anything that does not have an h better cancel. The 1 wasn't going to cancel, so I knew I made a mistake. So I went back and fixed it. It's okay to make mistakes. Just make sure you can fix them all over h. Now, if you're really good at the algebra, and I know you are, I can factor out an h now. Let's just skip that step. So this becomes 4x plus 2h all over h. H's cancel. This just becomes 0 because we're letting h go to 0, and we're left with 4x. So our derivative is 4 times x. Very easy to do. We're not done, because now remember we want to find the slope at x equals 3 up here. I want to find the slope at x equals 3, and that's going to give us f prime of 3 is 4 times 3, which is 12. There we go. All right, join us for the next video. We're going to take a look at what we call a tangent line. Very easy to do. See you then.